First, let's look at what is standing wave. I'll move my wrench up and down, which send out the pulse or wave packet. You can see it dies out pretty soon. That's because of damping. So I'm going to set damping to 0 and do it again. And you can see now the wave packet is traveling back and forth. To build a standing wave, I'm going to send out another pulse using the wrench. When the first pulse reflected from the right hand side, I'm going to send one from the left end in the same direction. So it's moving down from the right and move down from the left. You see they meet at the middle. Now it's hard to call this a traveling wave because you can't tell whether it's moving left and right. What you see is at the middle of the string, they add constructively. A peak is meeting a peak, or the trough is meeting a trough. So the middle has a bigger amplitude, and that bigger amplitude is moving up and down as if it's standing there. To make a good standing wave, I have to move the wrench up and down in a sinusoidal fashion continuously. When the beginning of the wave arrives at the middle of the string, I'm going to move it back towards 0, and when the wave arrives at the right end, I'm going to move the wrench down. So let me do that. So up, back, down, back, up, down, up, down. Each time you add a little bit energy to the string, and if you do that, in a few moves, the energy adds up, so you end up with a big amplitude. It's a little bit too big. I can use damping to make the amplitude smaller, and it looks nicer too. So maybe a little bit more. So now I have a not so bad looking standing wave. This is the first standing wave. It has the lowest frequency, also called fundamental resonance. Now I'm going to make the second standing wave. The first, or the fundamental standing wave, has one antinode. That is where the amplitude is big. The second standing wave will have two antinodes, so the amplitude of the oscillation will be big at the quarter of the string and 3/4 of the string. To do that, I have to move my wrench double the frequency, which means I have to move my wrench down when the wave travels to the middle of the string rather than the right end. Up, back, up, down, up, down, up, down. Yeah, the key is you add a little bit. Once you find the rhythm, you can add more and more energy by moving a little each time. So now I have the second standing wave. I'm going to turn on the damping to make it look nicer. So there we go. To make the third n equals to 3 standing wave, I have to move up and start to move down when the wave travels to the 1/3 of the string. So basically wrench is up, back, down, like that. It's 3 times the frequency of the fundamental. So I'm going to start doing that. Up, down, up, down, up, down, up, down. Once you see the rhythm, just keep moving at the same rhythm. Okay, and you can turn on damping a little bit to make it look nicer. That is our n equals 3. To make the n equals 4, the fourth standing wave, it's a similar idea. Now you have to start moving the wrench down at a quarter when the wave travels a quarter of the wavelength. So basically moving the range up, and when it's here, coming back, and when it's at the quarter, going down. So okay, I'll do it. It's even faster. So up, down, up, down, up, down, up, down, up, down. Once you see it's building up, just follow the same rhythm. And make the amplitude bigger. And you can turn on the damping. Yeah, pause to take a look. It's 1, 2, 3, 4. 4 amplitudes. 1, 2, 3, 4. So it's, although it's not very pretty, it's n equals to 4. To try n equals 5, you have to, start moving down when the wave travels to a fifth of the wavelength. Get even faster. Well, what you want to see is the wave doesn't go left and right, and this one is not very good, so I can try it again. Okay, so this one, although it's not very good, the shape is not very good, but it doesn't look like it's going back and forth. It's just a bad shape. So you can turn on the damping to make it look nicer. And if you pause, you can see this is 1, 2, 3, 4, 5. That is n equal to 5. So you can use this one for n equals 5. Now let's try n equals 6, which means you are going to move the range up and try to come back to 0 when it's right here, and start going down when the wave travels a sixth of the wavelength. So it's going to be quite fast. Well, let's try it again. The thing is, once you see the rhythm, you have to follow the same rhythm. This one seems it's moving left and right, so that's not very good. So let's try to... No, that's not very good. Turn on the damping. Maybe a bit more. Okay, let's pause to see. Okay, this is 1, 2, 3, 4, 5, 6 antennas. So we are going to use it as our n equal to 6. You can see it's not that good, but we can use it to measure the frequency of the 6th standing wave.